Welcome back. We have reached on part 5 of bubble sort algorithm. In today's video, we are going to optimize our bubble sort algorithm's code. So let's start. Let's suppose we have an array in which 2, 1, 3, 4, 5, 6 elements are present. Before applying bubble sort algorithm in it, our array looks like this as we apply our algorithm in it. Just after pass 1, our array will look like this. Array gets sorted out after just pass 1. Now the algorithm just can't stop after pass 1. It will run for all the passes. Although our array is sorted out in just pass 1, this algorithm will run for passes 2, 3, 4, and 5. In these passes, there will be some constant time taken to compare the adjacent elements of array in respective passes. So to avoid this, we are going to use the concept of flags in our code. Here, our aim is to avoid the useless execution of for loop for leftover passes. First of all, we will initialize a variable named flag, which has integer data type. Now, after the first for loop, which is used here to execute passes, just after that, we will assign 0 to flag. Now, if the comparison line of code was executed, it will directly indicate that the swapping is made. So to keep in record that how many times we swapped the elements of the array, we will use the line flag ++. This will increment our value of flag by 1 for every swapping done. So, at pass 1, the if statement is executed for index 0 and 1. So will the value of flag will increment by 1. Now, for rest of the indexes, if statement will not execute. When we finished at the last index for pass 1, our control will go to the next line, which will check that if any element is swapped or not. Here, 2 elements were swapped. Because of that, the value of flag was incremented by 1. This makes this line of code false, and under it, no code will run. Now the control will go back to the for loop, and our execution for pass 2 will run. Now in pass 2, for every index no if statement will execute, so flag will be not incremented, thus leaving the value of flag as 0. And after execution of all the indexes of pass 2, control will go to the next statement. Here, it will be checked that if any element present in array is swapped or not. In pass 2, no element is swapped, indicating that our array is sorted out. So this statement becomes true. And our for loop that is used to execute the passes will break, and we will get our desired array. So now let's talk about the running time complexities after the optimization of code. First, let's see about the running time complexity for comparison made. In best case, we need to execute minimum number of passes to minimize our runtime. Here, pass 1 has to always execute, because in pass 1, it can be checked that if the array is sorted or not sorted. So, our complexity for comparisons made will be sigma of n-1, because pass 1 will be definitely executed no matter what. And we have studied in previous videos that the number of comparisons made for n elements in pass 1 is n-1. In worst case, complexity, maximum passes has to be executed so that our runtime is worst. It is same as the previous one, big O of n square. Now the average running time complexity will be the sum of all the possible cases divided by the total number of cases, which also comes out to be n square. Running time complexities for swapping made is same as the before code optimization. No changes. So this was our code optimization video on bubble sort algorithm. In next video, we will be talking about the advantages and disadvantages of bubble sort algorithm. Till then, keep grinding.